this lesson is an extension of knowledge on the relationship between discriminant and nature of roots. So what you see here, all right, we will be talking about the relationship between the intersection of the line and a curve. Right, so what you see here is a pair of simultaneous equations involved. So in the first case, the first scenario, what you will see here is you will have a line intersect with the curve. So in this case, it intersects at 2 points, and hence discriminant is greater than 0. The second scenario, instead of the x-axis, right now we have the line intersect the curve at only 1 point. In this case, this line, there's a special name, that is, we say that this line is a tangent to the curve. So since there is only one intersection point, so therefore we say that the discriminant is equal to 0. So the third scenario here that we are referring to, it would be when the line does not intersect the curve at all. So in this case, we say that there is no real root between the line and the curve. And hence, since there is no real root, so therefore discriminant is less than 0. So let's see how we can apply this concept in solving this question 4a. So what we see here is we get a line which is y equals to m plus 3x. And this line intersects the curve y equals to mx squared plus x plus 2. So the keyword here, the first keyword that we are referring to is the word intersect. Now, so with this word, right, a lot of students will have the misconception that just simply assume that the discriminant is greater than 0. Now, let's see what happened here. Now, so when discriminant is greater than 0, we know that is when the line intersect the curve at 2 points. So that is why we have b squared minus 4ac is greater than 0. But however, if you look at the question closely, you notice that the question did not indicate whether the line intersect the curve at 2 points. So what could be the other scenario? So the other scenario that you can have is the line can also intersect the curve at only 1 point. So not necessarily 2 points. So therefore, in this case, we will need to consider the other condition, that is discriminant is equal to 0. So putting these two together, hence we will note that the discriminant, instead of greater than 0, it will have to be, take a look at this, right? So the discriminant, it has to be greater or equal to 0. So it's a combination of these two conditions. So given with this, so we can start to apply, right, the simultaneous equation concept. So putting these two together, we substitute y equals to m plus 3x into the curve, which is mx squared plus x plus 2. Combining these two, we will be able to get a quadratic equations over here. All right, so with this, you must be able to identify what is the coefficient of x squared, which is m, and the coefficient of x here, which will be -2, and the constant term, which is c here, will be 2 minus m. Now, before we proceed, we must be able to identify the next tricky thing in this question, which is this keyword show. Now, when it is a question asks you to show, it simply means that you are supposed to show this particular condition. That means you must derive b squared minus 4ac greater or equal to 0. So given this particular situation, you are not supposed to simply just state this condition. What you should do instead is to find out what is b squared minus 4ac. So when you substitute the value of a, b, and c into the discriminant, all right, whereby we have b, which is -2, so b squared minus 4a and c. So when you substitute this, you will be able to derive to this quadratic expression, which is 4 minus 8m plus 4m squared. So if you do a little bit of your algebra here, you notice that you can factorize the common factor, which is 4, and then you will get a simpler quadratic expression here. And this quadratic expression can be factorized till you get 1 minus m bracket square. All right, so this expression here, it is also the same as 4 bracket m minus 1 square. So do take note of this. So over here, you will need to work out what is b square minus 4ac. So given here, how can you show then, all right, to get the desired b square minus 4ac greater or equal to 0? So we will need to continue to move on to the explanation. So given this, all right, the explanation will involve, since you have the term, the perfect square term, 1 minus m square is always greater than 0, because given a perfect square term, the smallest possible value of a perfect square term is 0. So because this is a perfect square, so all the values that come from here, because of this perfect square has to be greater or equal to 0, we are able to then deduce that the discriminant b square minus 4ac, it has to be greater or equal to 0. And with this condition, hence we show that the line is actually intersects the curve at least one point. So over here, what I will want to link back is we are actually applying our peel over here. So this last part here is actually our link. So link, that means you simply just restate what the question asks you to prove. This, I just want to highlight the important points again, because the question asks you to show. All right, the question asks you to show. So therefore, if you start off the solution by stating the condition discriminant greater or equal to 0 at the beginning, right, no marks will be given over here because it's considered as presentation error. Now, and the second common error that we observe is this, because what you observe here is this expression 4 minus 8m plus 4m squared. This is an expression. It is not equation. So therefore, you cannot just simply divide the whole expression by 4 and therefore only left with 1 minus 2m plus m squared. So do take note of this. Yeah. Now, so once we are done with this, then we can proceed to part B. So in part B, what we see here is we are supposed to use the result in part A to actually derive the answer for part B. So the keyword that we are talking about here is the word hence. So once we see this word hence, you need to know that, as I mentioned earlier, the result has to be derived from the previous part A. So therefore, if you are not using part A, right, no marks to be given here. So given this situation, so therefore, how can we present the answer? So it's actually very simple. So for the line to be a tangent to the curve, we know that there is only one real root. So what is the condition for one real root? So we know that for one real root, we know that the discriminant b square minus 4ac, it has to be equal to 0. So given this, we proceed. So earlier on, we have already derived the discriminant, which is equals to 4 bracket 1 minus m bracket square equals to 0. So for this to be equal to 0, so therefore we are able to derive or to state the answer. That's why you notice this word is state the value of m, and hence we have m is equals to 1, and then we are done. So we need not to simplify and to derive the whole expression for b square minus 4ac again.